chose to implement a bubble sort algorithm which sorts data set or an array of objects, and I have a data set of 2500 elements which I have in a external text file which I have imported in the program, and then I have implemented the bubble sort algorithm, and I did all this in C, and I've used the OMP.h library, which is short for OpenMP, and I've used for calculating the execution time, I've used time.h library, and the rest two are standard libraries which are used for getting input and printing output, and for some many other necessary functions. The first function I have here is the bubble sort with parallel execution. I am taking in an integer array and the length of the array, and these two commands are the commands which I have used for running the parallel execution. The first line allows you to change the number of threads that we can use, and the second line is the command that executes the outer for loop in a parallel execution. By default, the inner for loop is executed in a parallel form, and because the bubble sort algorithm has a time complexity of n square, n being the length of the array, we can use the parallel execution to demonstrate the lesser time that is taken for parallel execution. The bubble sort basically sorts the array that we have given by checking. It checks one element and checks it with all the other elements, and a number which is in the higher position, if it is lower than the current number, it swaps it. And these three lines are the swapping algorithm, and this is the same bubble sort algorithm which I have did in a sequential manner. Here you can notice there is no pragma OMP parallel commands, so it executes sequentially, and this is the function I have written to read from the data set that I have in the external data set that I have, and these are standard commands and file, and this is to create a file pointer, and to this if condition is to check whether the file exists or not, or if it can open or not. And these commands are for getting the out of the array, reading the data, and then we're putting it in a form of an array and returning it. And this is the main driver function that I have used, and you can see the first three lines are for reading from the data set. The next three lines are the bubble sort sequential execution function I call, and the rest two statements are. First one is I have initialized a variable of data type clock_t, which will give the current time, which will store the current time, and clock of function will give the current time. And I have initialized another variable named n, which also takes in the current time after the execution of the program. Since these three lines execute sequentially, only after the current time is taken and stored in start, the next command, that is the function call of bubble sort sequential, will run. Only after the only and immediately after the function call is done, the clock is again measured and stored in n. So we can find the execution time that is taken by the sequential sorting by finding the difference between the end and start. And since these are function returns, we have to divide the difference by clocks per second. Clocks per second, which I have done here, to find the amount of time taken in seconds. And these three commands again, for it is used to measure the time for parallel execution of the same bubble sort. And this again initializes a variable start2, measures it and stores the start2, and after that is done, it executes the bubble sort parallel execution, and then after that is done, immediately the clock is again stored in N2, and I find the difference to find the execution time. And if we run the program, we get the output, and we see a time difference between the sequential execution and parallel execution. We can change the number of threads that is involved in the execution of the program. Let's say to 7, and then we can check it. And after it's sorted, we can see a bigger difference than we saw with just 4 threads, and almost less than half of the time that is taken by sequential.